Welcome to another section on old guy physics, and the topic for today is concave and convex mirrors. Okay, one of the things that might be helpful is that when you look at the diagram, you can tell that this one is concave. And the way that you identify that is that you notice where the object is located, and it is always in front of the mirror, and so this one appears to be caved in. And so this is a concave mirror. The C right here stands for the center, and it's actually the center of the curvature. When I drew that line, I was using that as the center. And then F stands for the focal point, and the focal point is always halfway between the surface of the mirror and the center. Now, when we draw these diagrams, we're going to draw two lines to find or to locate the image that the mirror is producing. Okay? And the two lines look like this. Let me grab a ruler. The first line is showing the lines of light, or the rays of light, coming in parallel with that center line. When it hits the mirror, it's going to reflect through the focal point. So that's line number one. A second line that we draw starts at the tip of the arrow, and it goes through the focal point first until it strikes the mirror, and then it reflects parallel. And I'm trying to make that line parallel like that. And so one line comes in parallel and goes through the focal point. The other line goes through the focal point. When it strikes the mirror, it goes out parallel. Where they intersect is going to be where the image is located. Now, once we've established where the image is located, then one of the questions that's often asked is, what are the characteristics of the image? Well, RSU is an abbreviation I've made for right side up, and USD is an abbreviation for upside down. And so we're trying to establish whether the image, which we see here, is upside down compared to the object, or whether it's right side up. And in this, if it's backwards or it's opposite or it's inverted, then it's going to be upside down. Okay? And so right away we know that this image is upside down. Now, we talked about this in class, but let me remind you about this. If it's upside down, that's tied to the concept of being a real image. Real images are projectable. You might remember the lab we did where we projected images on a screen. If it's right side up, which we'll see in a minute, then it's tied to the word virtual. The word virtual means that the image only appears in your eye. Then we're interested in the size. You actually look at this arrow right here and compare it with the object I started with, and you can tell that this one's a little bit shorter, so we would say smaller. And then where is it located? It's located between the C and the F, and so we could say between C and F. If we do the math, which we'll talk about in a second, we can actually get a numerical value for where that's located. Let's look at the math now. We've got the formula 1 over F minus 1 over DO, is equal to 1 over DI. I've given a value for the focal point to be 10, so that's 1 over 10 minus 1 over 25 is equal to 1 over DI. We first solve for a common denominator, which is 250. And you get that easily because all you do is just multiply the two denominators together, and that gives, it's not the lowest common denominator, but it is a common denominator. And that also makes it easy because then the 25 goes here and the 10 goes here on the top, and so we end up with 25 minus 10 on the top, which is going to be 15 over 250. And then when we flip it over, we have to flip the problem over to solve for the actual distance. 250 divided by 15, I believe, is 16.6 repeating. And if you look at this image right here, if that's 10 and that's 20, you can see how that could be 16 point, let's just make it 16.7. It's in the ballpark for being a correct answer. If you have any questions about that math, please see me about it. Let's come over here and take a look at this next diagram. Again, you can see that the object is in front of a curved mirror and it's caved in, so this has got to be concave. And we're still going to draw some similar lines to the ones that you saw in that diagram over there. One of the things that's interesting about this is that when you use a concave mirror and the object is in front of the focal point, then it's acting like a makeup mirror. A makeup mirror makes an image that's larger and it's right side up. The young ladies use that makeup mirror to get a larger view of their face, so when they're putting the makeup on, it goes where it's supposed to go. Now, line number 1 is still going to be the same. You're going to draw a line in parallel, and then it's going to reflect through the focal point like that. But we said in this diagram that we were going to let the line go through the focal point first, and then it was going to go parallel. Well, if we draw a line from the tip of the arrows through the focal point, it's never going to strike the mirror. So on this diagram, I usually put a big dot right there on the focal point to remind myself that I need to go from the focal point through the tip of the arrow to the mirror, and then it reflects parallel like that. Now, you look at these two lines, you see that they don't appear to ever come together on the left-hand side of the mirror. And so we're going to extend those lines backwards behind the mirror in this fashion here, and the image is located here. The image is located in or behind the mirror. Now, we said this was like a makeup mirror. That image shows exactly what I was talking about. If that's the object, the image is much larger and it's right side up. Now, we said over there that if it was right side up, it's virtual. So we've got a right side up virtual image, which is larger, and it's located behind or in the mirror. And then we could do the math, and it actually supports that answer completely. Look at this right quick. 1 over 10 minus 1 over 5 equals 1 over di. Common denominator is going to be 50. And when we flip the two denominators, it's going to be 5 minus 10. Well, 5 minus 10 is going to be a negative 5 over 50. And when you flip it, that's going to give a value of negative 10. Now that diagram doesn't quite show 10 centimeters, but technically it should be negative 10 centimeters behind the mirror. And so with the objects in front of the focal point, we should be looking for an image that's behind the mirror. If we look right here, when the object is behind the focal point, then we should look for an image that is upside down and it's also on the same side as the object. If you have any questions about that, touch base with me.